So solve each equation and write a justification for each step. So we have m over negative 5 plus 3 is equal to negative 4.5. So what do we need to do first to solve for m here?
Don't you take negative 5 and multiply it by both sides?
Before we do that, what can we do first?
Minus the 3.
Minus the 3. And what would our justification for this step be?
Subtraction property of equality.
Subtraction property of equality. So now we get m over negative 5 is equal to negative 4.5. What can we do next?
You mean negative 7.5?
Oh, 7. Yes, you're right. Negative 7.5. What do we do next?
Multiply the negative 5 times 7.5.
Now we can multiply both sides by negative 5. And what would our justification for this step be? Multiplication property of equality. So we get m is equal to 37.5.
Negative 37.
It's positive because remember, a negative times a negative is positive.
Oh, yeah.
Okay, so that's 17. Now let's do 18. We're going to do the same thing. So we have negative 47 is equal to 3x minus 59. We can add 59 to both sides. And what's our justification? Addition property of equality. So we get 12 is equal to 3x. What can we do next? Divide both sides by 3. And what's our justification here? Division property of equality. And we get 4 is equal to x. So this one is 18. So let's look at 19. Identify the property that justifies each statement. So we have a plus b is equal to a plus b. Reflexive property. Perfect. Reflexive property of what?
Equality.
Equality, because there's an equal sign. 20 says if angle RST is congruent to angle ABC, then angle ABC is congruent to angle RST.
Symmetry property of equality?
Symmetric property. Symmetric property of what?
Of equality, because
Are these equal signs? Congruent signs.
congruent.
So symmetric property of congruence. 21 says 2x is equal to 9 and y is equal to 9, so 2x is equal to y.
is it transitive?
Transitive.
Because there's equal signs?
Yep. Transitive property of equality. So remember, in transitive, if we have 2x is equal to 9 and y is equal to 9, we get rid of the things that are common and set the other two equal to each other. So let's look at 22. It says we're going to use the reflexive property of congruence. So it says figure ABCD is congruent to
ABCD.
figure ABCD. In reflexive property, it's just the same thing. Symmetric property of equality we're going to use in 23, which says if the measure of angle 2 is equal to the measure of angle 5, then
Measure of angle 5 is equal, congruent to measure of angle 2.
measure of angle 5 is equal to the measure of angle 2. So in the symmetric property, we just flip. So if we have 2 is equal to 5, we change it to 5 is equal to 2. Okay, and 24 says we're going to use the transitive property of congruence. So if AB is congruent to CD and AB is congruent to EF, then what did you say? CD is congruent to EF. Perfect. So we have the ABs that are in common. We got rid of those and just set the CD equal to EF. Okay, let's look at 25. We have a proof. So fill in the blanks to complete the 2-column proof. It's given that TU is congruent to UV. So they put the arc marks here, the tick marks. So we know that those two segments are congruent. Statement 1 says that TU is congruent to UV. What's our reason for this? Given. Perfect. Next says we're going to use the definition of congruent segments. What's the definition of congruent segments? Segments that are congruent are what? So if we have two segments that are congruent, then that means that we have two segments that are equal. And if we have two segments that are equal, then we can say that we have two segments that are congruent. That's the definition of congruent segments. So if we have two segments that are congruent here, then what can we say about those two segments? They're equal. So we can say TU is equal to UV.
So wait, how is it equal?
By the definition of congruent segments. If they're congruent, then we know that they're equal.
Okay.
The reason for step 3 says we're going to use the segment addition postulate. What's the segment addition postulate?
Would it be segment TU plus segment UV? Oh.
What's the segment addition postulate? If we have two segments here, those two segments added together are equal to the whole segment. So what can we put for our statement in C? SU plus UV is equal to SV. Perfect. And then 4 says SU plus TU is equal to SV. So they got rid of this UV and plugged in TU because we know that those two are equal. So what's our reason for step 4? Substitution. Perfect.
Wait, how's it substitution?
Because we got rid of something and plugged something else in its place. Substitution property of equality.
What did we get rid of?
We got rid of the UV and inserted the TU because we know that TU is equal to UV. Okay, so now let's look at 26. Find the value of each variable and name the theorem that justifies your answer. So how can we find W here? 3W is equal to 135. What theorem tells us that these two are equal?
I just know because they're on top vertex.
Vertical angles. So the vertical angles theorem. So now we just solve for W by dividing 3 on both sides, and we get W is equal to 45. Okay, let's move on to chapter 3. Number 1, we have a pair of skew segments. What's a pair of skew segments?
Ones that don't have anything to do with
A, B, and E, F.
A, B, and E, F. Perfect.
Yep, BC.
B, C, and what else?
GE.
Perfect. B, C, and D, E are skew segments also. So remember, skew segments don't intersect and they're not parallel. They're going in opposite directions. Number 2, what's a pair? What was that? D, F, and what else?
A, B.
Yeah, those would be skew. What's a pair of parallel segments here?
A, B, and D, E.
A, B, and D, E. Perfect. What's a pair of perpendicular segments?
F, E, and D, E.
F, E, and D, E. Yep, that works. Jeremiah, what was the one that you said?
Oh, so it's
Same thing. All right, what's a pair of parallel planes?
D, E, F, and A, B, C.
Plane DEF is parallel to plane ABC. Perfect. So let's look at number 5. Identify the transversal and classify each angle pair. So we have angle 5 and angle 2.
corresponding. No.
What's our transversal?
L.
So our transversal is L. So this line is our transversal. What would these two angles be?
Corresponding.
Interior.
Alternate interior, because they're both on the inside of the other two lines.
Would 3 and 4 be corresponding? Or I mean 3 and 2.
3 and 2 would be corresponding, yes. So let's look, yes. Let's look at 6. What's the measure of angle WYZ? 90. So if we're looking for this angle here, we know that this angle and this one are going to be, what type of angles are these?
Same side interior.
Same side
They equal
interior,
180.
so they equal 180. So if we have one that's 90, the other one's also going to equal 90. Well, I mean, then what's x? 90. Okay, let's look at 7. We're finding the measure of angle KLM, so this angle here. How can we find this angle?
You would put 26x plus 22 equal to 38x minus 14.
Let's look at 9. Name the shortest segment from point K to LN. So we're going from this point to this segment. What's our shortest segment here?
KM.
KM. Remember, the one that's perpendicular is going to be our shortest segment. So this segment is perpendicular. How do we write and solve an inequality for x here?
X minus 5 is less than 8.
X minus 5 is less than 8. And it's less than because we know that KM is our shortest distance, our shortest length. So what can we do to solve this inequality now?
X, you'd add the 5.
Add 5 to both sides, so we get x is less than
13.
13. Perfect. Okay, use the slope formula to determine the slope of each line. So we can use the slope formula, but since it gave us the picture, what can we do? Count. So what's slope?
Rise over run.
Rise over run. So what's our rise?
5.
So we're going up 5. And how many are we running? So 5 over 3 is our slope. Okay, so now for 12, we actually need to use the slope formula. So what's the slope formula?
y2 minus y1 over x2 minus x1.
So y2 minus y1 over x2 minus x1. So if we're finding the slope for EF first, we have our x1, y1, x2, y2. So what's our y2? 4 minus our y1.
2.
And our x2
Negative 3.
minus our x1.
8.
So we get 2 over negative 11. So that's our slope for EF. And now we have to find the slope for GH. So we have our x1, y1, x2, y2. So we plug in our x2 first, which is 3, minus, or we plug in our y2 first, which is 3. Then our y1, so minus 1 over x2, negative 4, minus 6. So we get 2 over negative 10. Are these two slopes equal?
No.
No. So are the lines going to be parallel, perpendicular, or neither?
Neither.
Neither. What do the slopes have to be for them to be parallel? The same.
And then for perpendicular, they have to be opposite reciprocals.
And for perpendicular, they have to be opposite reciprocals. Perfect. So let's look at 13. Write the equation for each line in the given form. So we have a line through 6, 1 and negative 3, 5 in slope-intercept form. What is slope-intercept form?
Y equals mx plus b.
Y is equal to mx plus b. So we need to find our m, and we need to find a b. So how do we find m? We find the slope. So what's our y1, or our y2?
5.
5, minus our y1,
So 1.
and our x2, minus x1.
Negative 3 minus 6.
So we have 4 over negative 9. So that's going to be our m. And then how do we find our b? We use one of the points. So we can use 6, 1 and plug in our x and plug in our y. So we're going to have 1 is equal to, now we plug in our m, which is 4 over negative 9. times 6, which is our x, and then plus b. So what's 4 over negative 9 times 6?
24 over negative 1.
24 over negative 9, which simplifies to
Yeah, negative 8 over 3. 8 over negative 3.
negative 8 over 3. So we need to add 8 over 3 to both sides. So we add 8 over 3, we add 8 over 3. So what is 1 plus 8 over 3?
9 over
9 over 3.
2. Oh, 11 over 3.
11 over 3.
Yeah. Because you have to get the common denominator.
Yeah, because we need to change the 1 to 3 over 3. So we find the common denominator, and then 3 plus 8 is 11. So we get 11 over 3 is equal to b. So now all we do is plug in our m and plug in our b. So we have y is equal to 4 over negative 9 x plus 11 over 3. So this is our answer in slope-intercept form.
Wouldn't it be negative though, or no? Because we already
For which one?
for the one we just did.
But for b? Well, we had negative 8 over 3, and we have to add 8 over 3 to both sides to get that to go away. So it becomes positive.
Oh, right.
Okay, let's look at 14. The line with the x-intercept 1 and y-intercept negative 2 in point slope form. What is point slope form?
Y minus y1 equals slope, and then in parentheses x minus x1.
Perfect.
Since we don't have a slope, do we just use one more?
How can we find a slope here? What are the 2 points that we have? We have the x-intercept, which is 1, and the y-intercept at negative 2. What does it mean to be an x-intercept?
Is that the slope?
What's the y-intercept on the graph? So what does it mean to be a y-intercept? The y-intercept's negative 2, so how's the graph going to represent that?
1 over negative 2 would be... And go down?
Right, so the x-intercept is where it's going to cross the x-axis at 1. So we're going to have a point here, because this graph is going to cross the x-axis at 1, and it's going to cross the y-axis at negative 2. So we have 2 points on this graph. So what are the coordinates for this point here? 1, 0. And what's the coordinates for this point? 0, negative 2. So now that we have 2 points, can we find the slope? Yes? So what is our y2? So let's call this our x1, y1, x2, y2. So now to find the slope, we do y2 minus y1, so negative 2 minus 0, over x2 minus x1, so 0 minus 1, and we get negative 2 over negative 1, which is equal to 2. So our slope is 2, so we can plug that in for m. What can we plug in for our y1 and x1?
0 for y1.
Can we just plug in one of these points? Yeah.
Oh, yeah.
So we're going to have y minus 0 is equal to 2 times x minus 1. So we're just plugging in what we have here. And this is our answer. So that's our equation in point slope form. So 15 says determine whether the lines are parallel, intersect, or coincide. What do we need to do first in order to tell whether the lines are parallel, intersect, or coincide? We put in slope-intercept form. So we have to get it to y equals the rest of the formula. So what can we do for our first formula here to get it to y equals?
Add the 3x to both sides.
Add the 3x. So we get 2y is equal to 5 plus 3x. So now we divide by 2. And we get y is equal to 3 over 2x plus 5 over 2. Now we're going to do the same thing for the second equation.
Is it okay if I put in this?
Yep, that's fine. So what can we do first to solve for y in the second equation? Subtract 6x. So we have negative 4y is equal to 8 minus 6x. And now what can we do?
Add 4.
Divide by negative 4. So we get y is equal to negative 2 minus, or plus, because we have a negative divided by a negative. And what does 6 over 4 simplify to? 3 over 2. So looking at this equation and this equation, do we have the same slopes?
Yes.
Yes. Do we have the same y-intercepts?
No.
No. So are these going to parallel, intersect, or coincide? They're parallel. Now let's look at 16. Our first equation is already in slope-intercept form, so we don't have to do anything to that. So we have a slope of 2 and a y-intercept of 1. What do we have to do to our second equation to put it in slope-intercept form?
You would minus the 2x.
So we subtract 2x from both sides. We get negative y is equal to negative 2x minus 1. Now what do?
Divide the negative 1.
We divide everything by negative 1. So we get y is equal to 2x plus 1. So we have two equations now that are the same. So are these going to be parallel, intersect, or coincide?
Coincide.
Coincide. What does it mean to coincide?
They're like on the same line.
They're the same line. So if we have the same slope and the same y-intercept, they coincide because they're the same line. Chapter 4. Determine whether ABC and PQR are congruent. Support your answer by describing a transformation. So what's happening here? We're going from xy to negative x. Is the y changing?
Yes.
Yeah, the y's changing signs too. So negative x, negative y. What type of transformation is this?
Translation.
Is it congruent?
What type of transformation is it?
Rotation?
Transitive.
Let's see. It's a rotation. And we know that rotations are congruent because the only one that's not congruent is a dilation. So if it's not a dilation, we know that they're congruent. So since it's a rotation, it's congruent. Remember, translation is when you're adding or subtracting to the x and y. But translations are also congruent too. So classify each triangle by its angle measures and side lengths. So how do we classify number 2 by its angle measures?
Equiangular.
Equiangular. And how do we classify it by its side lengths?
Equilateral.
Equilateral. Number 3, how do we classify it by its angle measures?
Obtuse.
Obtuse, because it has one angle that's greater than 90. And how do we classify it by its side lengths?
Scalene.
Scalene.
Is that right?
Yep. Scalene, because all 3 sides are different lengths. Okay, number 4. How do we find the measure of angle N?
You do y plus y equals 120.
Y plus y is equal to 120. So we know that the 2 remote interior angles are equal to the exterior angle. So we add the 2, y plus y is equal to 120. So we get 2y is equal to 120. We can divide by 2, and we get y is equal to 60. Is that our answer?
Yes.
Yeah, because we could just plug it in, and we get y is equal 60 degrees. Okay, number 5. Given triangle PQR is congruent to triangle XYZ, identify the congruent corresponding parts. So we have PR is going to be congruent to what? XZ, perfect. And next we have angle Y is congruent to what? Angle Q. Okay, and this is a good stopping point for today.